Good afternoon, everyone. We are pleased to introduce our speaker for today's session, Mr. Richard Shum. He has over 33 years experience in software development. He started his career as RPG developer. He has been always looking to do better ways or provide utilities and mechanisms to simplify everybody's life. And Richard comes with a vast experience in many platforms, including IBM I, Windows, Linux, and Macintosh. During his career, he started RJS Software Systems and served as president and CTO until the company was acquired in 2014. Richard currently works for Pegasystems as a senior solutions consultant. Welcome, Richard.
Hello, thank you. Thank you for that introduction. And so I had to come up with an interesting name for this title, and the best thing I thought, because it really is focused on RPG using open source. I said RPG makes friends with open source. That sounds like a good title. So sort of the idea is, while many of you are doing RPG and CL development, and more of you might be developing best-of-breed apps and utilities in Python or Node or PHP or in Pace and Linux, you might also be recruiting a new generation of staff members to help with some of these integrations. So after the last time I did this session was interesting. I actually got somebody that was doing Python that didn't know much about IBM I, and they thanked me for doing the session because they gave them more insight into how they can start integrating what they're doing in Python into the IBM I application. So that was kind of fun. But often these two worlds don't come together nicely. I always like to use the analogy of the Reese's Peanut Butter Cup, where you have two great tastes in a single candy bar. That's sort of a 70s reference. I have to do that for my kids all the time because I like to have them see some of the commercials that we used to see. But in the case of IBM I, it's the idea of taking classic RPG and CL and then marrying that up to the open source application. So during our session, you'll learn useful ways to integrate between the traditional IBM I languages, such as RPG and CL, with the open source stack available in IBM I, allowing you to do many of the things that you thought weren't possible with RPG and CL. And yeah, just another, I'll go quickly. I think most of the highlights were covered here as far as my background. One of the things I think is most important, so I still do a lot of outside, even though I work for Pega as my 9 to 5, I do a lot of outside consulting. I do training, do some work with the Sidon group as well. But I consider myself a lifelong learner after 37 years of doing development and working on IBM I and those environments. And a couple of years ago, I also authored a commercial IBM I Git client, because more and more people are trying to start doing source code management using RDI and PDM and SEU, and they may not have opted out into a higher end source management solution or object management solution. And then I also do a lot of open source contributions regularly on my GitHub open source page as well. But I try and learn at least one new thing per day to sort of keep my mind going. So my journey, just a little background on me. So I started back in the 80s when I was on the System 36, and I did my first integration between a DOS Turbo Pascal application and a System 3650-250 application in Windows 3.1 via screen scraping. So you can see all the connectivity things that have come and gone since then, and most of them are still around in some fashion. And of course, all the various development environments that we have as well. So I consider from 1984 to today to be one of the most eventful and the most interesting computing eras, because I went pre-PC all the way to where we are today with our smart devices and that sort of stuff. Although, of course, it's become much more painful in some ways because we have to be vigilant with the security in all of our applications, with ransomware and email phishing attacks occurring regularly and those sorts of things as well. So I would say my one word of wisdom, as I said for everybody, is that if you can learn one new thing to be excited about every day and spend maybe 1 to 2 hours per day or a couple hours a week learning something new to keep yourself fresh, I think that's a good way to keep things exciting. And it doesn't have to be coding. In a lot of ways, I don't do coding for most of my day. I do maybe about 30% of my life is coding nowadays, and the rest of it is often doing process design or communicating with teams or scoping out a project or doing a pre-sales engagement or something like that. But just find something that excites you, and it may or may not be IT related, but just something that you can spend extra time on. Okay, so before we dive in, we'll talk a little bit about why considering using RPG and open source apps together. Then I'll take you through some concepts, and then we'll show you how to start utilizing open source apps seamlessly with your RPG, CL, and even COBOL apps if desired. We'll be focusing on utility applications mainly that can be integrated via RPG and CL rather than building a web app, or which is a whole topic in and of itself. Then we'll provide an introduction to my open source tool called QShell-NI, which is the plumbing that will greatly improve your relationship with calling open source apps from RPG and CL. And then we'll walk through the logic flow, thought process changes that might be needed when integrating open source calls to traditional apps, and then review some useful examples as well. And then, of course, we'll pause for questions along the way. If you have questions, if you do, please ask them either over the air or in the chat. If I can answer right away, I'll do so. Otherwise, I'll park and lot them until the end, and we'll try and finish that up about 7 o'clock as well. And then you'll have my email as well in case you need to email me questions if you're shy. I'm not going to dive into the various Unix shells available today, but Andy Eunice from the UK recently released a short video on this. I think it's about a 10-minute video that's fun to watch, but you can ultimately think of QShell and Paste and Bash as the ability, as your Unix command line and the ability to call AIX and Unix programs on IBMI, and also using open source packages. So this would be a kind of a nice overview video to watch. For our purposes today, we'll assume you know a little bit about calling QShell or Paste, but even if not, you're going to learn a little bit about how to use it, and then you can come back and view this tutorial later, because we're going to be working mostly from the CL side of the fence. So you don't really have to learn a whole lot of shell stuff for today's purposes. So why consider using RPG and open source together? So you all probably have a toolbox of code and other things that you use on IBMI when developing applications. I always think of all the RPG code. I never do anything from scratch. So I've got previous RPG programs or service programs or copybooks or CL programs, SQL, DDFs, all kinds of source members that I might want to reuse. Back in as a sort of a history lesson on when I got started using some of the AIX stuff is when I was running, and this is about the 2005, 2006 time frame, when I was running RJF software, we needed to be able to integrate calls to QShell and Paste and know that they ran successfully, because we were dealing with customers' scanned images and other important document content, so we couldn't afford to lose any of those documents. So I discovered how nicely you could start integrating things like there was a component called TIFF-Lib and GhostScript and other tools that you could use for TIFF image processing and PDF document processing and manipulation within our classic IBMI job streams, since we did a lot of document management. Often we would process out files with lists of documents from the IFS or data queues, and then do some conversion into TIFF or PDF, and then call QShell and Paste processes as part of that document processing, and we could not afford to have corrupted documents. So by trial and error, we discovered there were some AIX binaries we could get to work really well in QShell and Paste, and then some that didn't work quite so well. And then so if you fast forward to today, over the past several years, IBM has made a ton of open source components available on IBMI, and they've done a great job of making these tool sets available for IBMI developers, including GhostScript for PDF processing. They've brought the most latest version of it, and then a ton more utilities that are available like MariaDB and Postgres and all kinds of different things, and all the core languages like Node and PHP and Python, and they can be used in conjunction with IBMI Access Client Solutions and installed with that method as well. So the open source explosion has had the net effect of exponentially expanding the number of things you can do with your IBMI apps that RPG and CL couldn't do by themselves, or often found it a real stretch to accomplish, where I could do it easier in another language. So RPG's come a long way, but the new wave of IBMI programmers will not always come out of school knowing an open source language, or actually flip it around. They may come out of school not knowing RPG, but they'll know open source. So it's a nice way you can start expanding your team's horizons when thinking about doing new applications, and how you can judiciously start using open source technologies without having too many languages in play. So when you start embracing open source tool sets with RPG and CL, it's a great way to start team building and exponentially expand your toolkit and build some great productivity apps together. Okay, this is a nice visual. I like this because it shows a simple depiction of what we'll be reviewing in our session, but I like it because it depicts a world of existing traditional 5250 interactive and batch applications starting to intersect and overlap with AIX and other open source applications running in Q shell and PACE. And you'll see why it's important for them to start intersecting and how they do that when we go through some of the how it works. But traditional IBMI non-screen-based apps can be run or submitted from Q shell or PACE. And then Q shell and PACE apps can be easily called out from traditional IBMI apps. So they start becoming ambidextrous. And this overlap allows you to more than triple the number of functionalities you have available to you from your traditional IBMI apps, which I thought was pretty cool when I started using this. So I used to get frustrated when there were things I wanted to do in RPG or CL, and I knew I had an easier way to do those things using a scripting language like Python or PHP or Node or PowerShell or C in Windows and Linux. And in today's world, there's virtually no limit to the integrations you can do between the traditional and Q shell PACE style applications. You just need the right plumbing to get things working. So to level set the new world concept, as I call it, let's first talk about how a typical IBMI job program flow might go. So this slide shows a general IBMI interactive or batch program flow as I visualize it. So a typical IBMI job has access to a local library called QTemp, which each job owns, and then this library can't typically be shared across processes. So I've used the QTemp library a lot over the years to hold temporary files that contain result sets or data queues or data areas, and I want those results to be private to my current job. And then as it runs, your process might call one or more CL commands or RPG programs in a specific sequence. And then that process might then run a CL or an RPG program or maybe even a COBOL app and pass parameters into it. And then that process does some work and eventually completes. And then the process might return parameter values or data to an output file in QTemp, or maybe CPF messages to indicate success or failure so your process knows how to react in the next steps. And then login information may or may not be written into the job log, or maybe you have your own custom log files that go to physical files or the IFS perhaps. I've started doing IFS-based log files more and more recently. So if there's a lot of, just one caveat too, and you may have run into this over the years, but if there's a lot of logging required, it might be a good idea to log to a physical file or an IFS file, even from your traditional jobs, because the job log appears to have a maximum size of only 64 megs these days. And if that maximum is reached, the job will terminate unless it's set to wrap the job logs, which means that job log information can get lost. So just some things to be aware of when you start logging a ton of different messages. So how does incorporating a Q shell or PACE-based call in the process change that traditional flow? So the main job still has a QTemp library, of course, so that doesn't change. You might still have a process that calls one or more CL commands or RPG programs, and then that process might also call a CL or an RPG program or even a COBOL app and pass parameters into it. And then this is where the difference comes in, is that you might want to call a Q shell or a PACE application from CL or RPG to interact with a web service, maybe perform a data translation or export a file or send or receive an email, and then write the results somewhere so that the calling CL or the originator can have access to that data. So when Q shell and PACE work needs to be done, ultimately it spins off a Q shell job with start QSH or QSH, and that spins up a new thread on the IBMI, which is ultimately a job. So if you ever did a work active job while you had a command running, you'd actually see there's two IBMI jobs that are running when you kick off a Python job or a Q shell script or something like that. So the problem comes in is that those new Q shell jobs, those thread jobs, don't have access to our original QTemp library. So they can't output directly back to there, or the original job log initially, because the PACE job is running as a different job. So the question becomes, how do you get that information back into your primary job? So one option is to make sure the Q shell job writes output data to an agreed upon file, maybe in a shared library. I often use a library name of TMP or some other library where I put shared objects. When I used to own RJS, we had one called RJS temp. Or maybe the data is written to an agreed upon IFS location as well. So both jobs may know where those files are at. But a nice answer, as you'll see today during today's session, is to use the Q shell and the pace output mechanism called standard out or standard output, or you might hear it called console output. So we'll talk a little bit more about that as we go, but conceptually, think of it as a way for desired return information from a pace job to cross the boundaries of those multiple threads so that information can be used back in your primary job. And then when that CL or RPG process finishes, because the Q shell for the pace job doesn't return a standard job log, we need to read and process that standard output information and then decide what to do with that return information. So then the Q shell job this is where the Q shell job would bring back maybe some informational messages, parameter data, or whatever you want in the standard output stream. And then that information can be parsed as return parameter values, or you can use the process return code to trigger a CPF error to indicate a success or failure. So your IBMI process knows how to react after that Q shell call ends. And then the standard output logging mechanism can be intercepted and processed, or it may or may not be written into the main IBMI job log. So we're going to show you the mechanics of how to do that. So it sounds a bit complex, but this is where the Q shell and I commands come into play to handle all the plumbing for you. So we'll show you how simple it is. And in reality, you probably will never even have to think about most of this, but it's kind of nice to sort of see a blueprint of how it works mechanically. But for the most part, what you're going to see is it's relatively simple with a single CL call. So before we look at the Q shell and I utility, let's cover how to get data, message, or return code feedback from a PACE application. So what is standard out or standard output as we call it? So standard out is a great way to communicate between a PACE and a Q shell app and communicate that information that came from that app, that log information, back to your traditional CL or RPG or your COBOL app. So standard out refers to the ability for any of your scripts and programs to write output data and messages to the console from a PACE or a Q shell application running within a Q shell session. So writing application output to the console in a PACE application is very similar to writing directly to the job log in an IBMI job. Data can be written in any format, including something as simple as a one-line message, to the extent you'll see in one of our examples today, where you can write a full JSON packet or a CSV packet as well. So you can pass a whole ton of different information bits back, not just single messages. And then that data from standard out can then be utilized or consumed from your CL or your RPG application to use that data. So we'll look at how that's done in a few moments. And then every Q shell PACE call will have a return code or an exit code that indicates if the command ran and completed successfully. So that's how we physically know, for the most part, if one of those calls ran successfully. So if you get a return code of 0 from your PACE call, that means it ran successfully. Or if you get a non-zero code, that typically means that there was a failure of some sort that happened when you made your Q shell or your PACE call or your Python call or whatever it was. So in either circumstance, the standard out log will usually contain additional output messages to help troubleshoot the cause of an error, just like your job log. When we look at the Q shell and I commands, you'll see a 0 return code will result in a normal completion of that CL command call. And then if you happen to have a non-zero return code, it'll actually cause the Q shell call to come back with a CPF 9898 that you can monitor for in your regular CL or RPG job to know if something failed. So you'll see the mechanics of how that works when we look at it. So this example, Hello World Python script, shows the script name on the first line, and then it shows Hello World on the second line, and then it illustrates the message that was passed back in double quotes as a parameter. So you can think of that as the console output that we can ultimately capture from this. So this happens to be, I'm running this from a Bash terminal session in this example, and you'll see a couple live ones when we do our live examples. So this example is that same Python script, except I messed it up because I wanted to show what happens if you happen to have an error occur in your script. So the Python processor found the letter ZZ in my sample script. So just kind of showing you here, I just injected some bad characters on line 15, and Python didn't know what to do with those, so it threw an error. One of the good things about scripting languages is they're really, like Python, they're really easy to use, but they don't compile until they actually get executed. So you actually have to run a script when you're testing it to see if it fails. So it's not like RPG or CL where we can compile it. So generally, you want to be able to handle errors or success conditions when you're working on calling your PACE apps as well, so that they can return either success or failure back to your traditional IBMI jobs. And then here's an example. There's a utility in PACE that IBM ships called db2util, and it allows you to do SQL from the PACE command line and then return results. And so in this example, you can see I'm actually just returning some CSV data, and then that output could be brought back, and I could use that from an RPG application. So in our demo section, when we show it today, you'll see an example of an HTTP call where we grab a JSON result file, and then we have a sample RPG application that will parse that and then write it back out to a physical file. So that's kind of sort of an end-to-end sample that you could potentially use to go grab a JSON file and then synthesize it back into a regular physical file through RPG. So that'll be an interesting example to see. So what is QShell on I? So QShell on I, so it's a set of CL commands that I wrote about 2 years ago, maybe 3 years ago, as a convenience wrapper over QShell and PACE commands. So I wrote this because I found myself constantly writing the same CL setup code to call QShell or PACE commands from interactive and batch IBMI jobs. And my CL and RPG code would be littered with handling code, making these things really messy to work with. So QShell on I simplifies it down to just running a single CL command, which you'll see when we take a look at it. But so it automatically sets up the environment variables needed for QShell multi-threading, so you don't have to set that up. It handles the command logging output or the standard out capture that we talked about. It allows any QShell or PACE command to be submitted to batch. So if you're using the Windows or the IBMI job schedulers or maybe a commercial scheduler, you can submit your PACE and your QShell jobs as batch jobs to run. Doesn't need an SSH session, or doesn't need to do direct calls to start QShell or call QP2 shell, which are available because we do that under the covers for you. And then commands can be called directly from your RPG or CL app, as you'll see in one of our examples. And then our commands will throw a CPF 9898 error nicely if we do get a fail from our PACE code. So we know, even across the boundary of that multi-threaded job, we know if that PACE job failed when it was trying to do the work that it needed to do, and our regular CL or RPG calls can handle that accordingly. So the QShell and I commands are front end for QShell, but QShell can automatically call PACE apps or bash to run scripts. So it's pretty much a common front end to all things QShell and PACE. So it could just be pretty much any command or any application you want to call. So the CL commands can be run interactively or submitted to run processes in batch mode. One thing to be aware of, and I found this out the hard way back when I used to work with Java a lot, but you need to make sure that if you submit any jobs to run in batch, that they have to allow more than 2 active threads. Because what happens is when you submit that job, you've got your primary job that we showed, and then any thread jobs or any PACE jobs that get spun off, it starts a multiple active threads. And those threads go away as each Python script ends or as each shell call ends. So I generally use user nomax or qsys nomax as my job queues, because those are kind of system background subsystems that we have available to us. And that'll keep your jobs from failing. I've done stuff where I've submitted them to QBatch before, and often that's a single-threaded job queue on our IBMI systems, and you might run into failures for some unknown reason. It's usually just because it couldn't spin up a Python thread or couldn't run a node job or couldn't run any one of those other PACE applications. So we'll be looking at a couple general use cases, but you can accomplish things like calling a web service, which we'll be looking at, that you could tie into things perhaps like Salesforce or Amazon or Microsoft Azure, other service providers. We'll look at an example of sending an email from the IBMI, or perhaps you want to query another database on IBMI, such as MariaDB or Postgres, or there's even SQL Server drivers now that you can use to reach out to an SQL server from Python or anything ODBC based, or SQLite. So any of those languages or database servers are available to you. And then the use for open source technologies on I is pretty endless nowadays. So the QShell and I wrappers can pretty much allow you to run any open source application you want to write, and then make it available for RPG and CL. So that's pretty cool. All right, so system prereqs for this. So so I'm not going to go through detailed prerequisites, but so most of the systems nowadays have the open source package management, so you would typically want that loaded up. You can load that through the IBM Access client or ACS. And then once you have that installed, you would generally install, if you're going to use the IBM Access or other ODBC drivers, there's a thing called Unix ODBC you want to install, because that allows us to talk out to other databases. There's also an SQL driver called FreeTDS you can install if you plan on making stuff talk to SQL Server. And then if you're using the older stuff, and then you install the QShell-NI or the QSHONI library from this GitHub site, which is my GitHub site. And then if you're using some of the older open source stuff, or if you have the license program 5733 OPS, if you can, you want to deinstall that now, because that's been deprecated by IBM in favor of the new open source package management stuff. So there's things like Git, and there's an older version of Python that run under there too, but I've seen customers get confused when they install the newer stuff and then have the older stuff, and then didn't have search paths set up correctly, and they were thought they were running the newer versions of Python, and it wasn't working correctly. So that's your general prerequisites. And there's what it might look like after you installed all your Python stuff. You just select every Python 3 package that you can find. Just this week, I think it was this week, IBM released Python 3.9 on IBM I, so that's available to you now if you're doing any of the newer Python, or if you happen to be using Node or something else, you could probably use that as well, but our examples are Python-based, so we're just noting that. And then installing QShell-NI. So this shows you how to go to my GitHub site and read the README page and install right from the website. So there's a save file installer out there. You can install directly by using Git and then building it directly on your IBM I. There's a build script out there you can run if you're adventurous that way. But there's a couple different ways that you can install this QSHONI library, and that's where all the commands live that we're going to be working with. All right, so once you have QShell-NI installed, there's a handful of commands that you can use. So we're going to go through the list of available QShell-NI commands, and then we'll do a demo of how to use those commands. So the QSH-exec command is the main wrapper around QShell that all the other commands use. So every one of my other commands that I wrote called this command, which in turn calls start QSH under the cover. So for the most part, you can think of it as a direct replacement for start QSH and QP term if you've used that before. And then, like I mentioned, it makes a call directly to start QSH after it sets up all the environment stuff like threading for us. And then it allows paste commands to be submitted as well, like we talked about. So think of things you might want to submit to batch, such as application startup scripts for web services. Maybe you've written a web app in PHP or Node or something, and you want it to run in the background as a service, or maybe you've got a Python app. So it allows you to manage those via the standard job scheduler, which is cool, and submit those processes. There's a CL command called QSH bash. So in the SSH shell world, often we're using a shell called bash nowadays. So if you are, this command basically calls QSH exec, but it puts a bash-c prefix on it. So it actually calls those commands using the bash command. So it's just kind of a convenience wrapper to be able to call any bash commands that you might want to do that run a Python or a Node script or something like that. Or you can just stick with, if you want to type it out all yourself, you can still use QSH exec as well and just add bash-c as a prefix to that. And then there's a command called QSH-py-run, which is more in tune to running Python scripts specifically. So it's mainly a convenience wrapper that runs a selected Python command line by passing a script directory, a script name as individual parameters. And then I have an older project called py-run out on my GitHub site, but I've added more and more to this QSH-ON-I library. So going forward, this QSH-py-run command is the one that will be maintained since it gets automatically upgraded anytime I upgrade the QShell and IBM I library with new features. And if you want to stick to running QSH exec with the first command we talked about, you don't necessarily even have to use this. You can just prefix Python 3, a space, and then any Python commands that you might want to run as part of QSH exec, because that lets you run a raw paste command line, which we'll be seeing in a moment. So this is kind of interesting. So QSH log scan is a convenience command to scan the out file that gets created after your Q shell or your paste command runs. So that's where the log comes back to. You'll see when we look at it. But so if you want to scan a standard output log for a success or failure value other than return code, you can use this CL command and it'll actually scan for a text value. You'll see an example of that. I'll show a real world example. So I've had scenarios where this command was useful because I called a paste application and for some reason, even though it failed, it returned a 0 return code. So I was talking about earlier where sometimes you didn't know that it failed. So in that off chance that I run into that, I would use something like this QSH log scan, and you can actually scan the standard out log messages, because often, even though the return code was 0, there might be something in the log messages that I could look for. So often I would scan for a specific text value in that log or some sort of partial match that would tell me whether it succeeded or failed. So that's where you can use this QSH log scan if you want to as well. So it's a great way to look for a generic value or a specific value within the log, and then throw an error if it's not found. This is just an example that allows you to do a quick check for IFS files or directories if you want to use it in your processes. And then this QSH path command automatically sets, a lot of people do not have environment variables set up for paste and Q shell jobs. So by default, this is embedded and will run as part of all of the QSH exec command, the QSH bash command, and it automatically sets up your path to the open source packages from IBM. So you don't have to set those up manually or go learn about setting up user paths in your home directories and those sorts of things. So you can pretty much just ignore the fact that this is there, but just know that it's setting that up for you, which is pretty cool. So each of these 3 commands have a set package path command on them, which will set that automatically for you. There's just a quick look at the QSH exec command with all its commands in its glory. And then just a note on temporary objects, because I always get asked this. So there's 2 places where I typically put temporary objects. So if I'm doing a paste job, I have a directory. So there's always a TMP directory on every one of our machines, but I create a QSH directory underneath that, and I create unique files for my temporary logs that I create in the IFS. So any paste job that runs is going to create a temporary log out in that IFS directory. And so, and then there's a QSH on itemp library that we create as well. You don't have to use that, but that's just one you can use to put a shared, so if you've got an out file that you previously put into qtemp, you can put it in this library, give it a name, and share it across your normal job and then your paste jobs as well, or if you want another shared library that you might want to use. And then on a general basis, I always tell people for cleanup purposes, when you IPL or if you do weekly cleanup, is make sure to do a regular erase in this directory when you don't have a bunch of production stuff going on to clear any temporary files, because everything that goes into this temporary folder is expendable. And then the same thing, you should always treat this library as expendable as well. Anything that goes here is a temporary object that can be removed at any point in time by a job. So that handles cleanup. And then, so on the QSH exec command, so you can see there's a command line that takes any Q shell or paste command line, and then we already talked about the set package path, which sets the path to the run command. And then there's always an out file. So this is, we talked about plumbing. How do we get that information back across the wire from that original paste call that we make, or that secondary threaded paste call? We always bring that information back to the primary job. So you'll always, anytime you make a call to QSH exec and you call your paste job, it's going to create an out file back in qtemp, which I think a lot of us are used to if we're doing classic programming. So there's an out file that gets populated called standard out QSH, and think of it as the equivalent of the job log from that command that you just ran in paste. And then there's also several additional options for handling those as well. So then your RPG and your CL and your COBOL apps can actually process that out file as well, or maybe you want to do a copy file of the contents of that and append it to your own log physical files. There's all kinds of ways you can handle that, but that always comes back when you're using the QSH exec commands or any of the other commands, so that's nice to know. This is a good parameter, so displaying standard output's nice to be able to see the standard output contents interactively from a green screen. So you'll see that when we'll do a little test here in just a moment, but it's nice for debugging because you can actually see those logs even though we're capturing them back to an out file. You can see them on the fly. And you would often use this only if you're in a 5250 session doing some development and want to see what's going on. In production mode, you probably would have that set to no. And then after running with display standard output no, it always still creates that out file after each call. So the good thing is you can process that. But there's also a couple other options that you can use that might be more useful as well. So the out file is always there for you. But you also have the ability, this is kind of neat, is you can take that result information from the call to your PACE job and actually write it to your primary job's job log. So we actually have a message, it's QSS9898. So any log information that came back as part of that standard out log that we talked about can be sent right into your primary job's job log. You'd want to be careful. I would only do that if you have small amounts of messaging. If you have like 10,000 messages and coming back from your PACE job for some reason, I probably would be careful about using this parameter. But if you have one or two things that you want to log as part of your primary job log, this is a nice way to make sure that's in the regular IBMI job log and not just the standard out file that we brought back in that out file. Another option, just like you have an IBMI, you can actually print that standard out log too. So you have the ability to control when you want it to go to an out queue. So maybe you want it to go to a spool file. You can control that spool file name for each of your jobs. You can control user data and print text. And then you would only use this in production. Most likely, if you want to capture those for spool files for auditing rather than going to an out file or an IFS file or something like that. But this is another great way to debug stuff if you want to be able to create printed job logs when your processes run. And then the delete standard out. The only thing I'll say about this one is just leave it set to yes. That just always makes sure those files in the /temp/QSH directory get cleaned up for you. So I would just say, in general, there's no reason to change this guy, but it's there, it's available to you. And then finally, more and more, I'm creating logs in the IFS. So this allows you, this parameter will take and write that information instead of, it'll always write it to the out file temporarily. You can write it to the job log if you want. You can write it to an out queue, but this will actually write it to an IFS file if you're choosing. And you can even, so you can choose to replace that IFS log file each time you run it, or you can append to it if you want an ongoing log for each of your applications where you're calling paste stuff. That's nice. You can have a single log for each application and just have it keep adding to that log with logging information each time that it runs. So it really depends on the logging needs that you have. There's just a quick summary of the sequence we talked about. So using the CL commands, embedding them, calling via Q command exec, passing commands, any paste commands, retrieving parameters, pipelining standard out directly back into your job so you can process it, and then sending standard out where it needs to go, wherever you plan on using it. So it's just kind of a quick summary of that whole sequence of how all that works. All right, cool. So let's do a little demoing. That's the fun part. All right, so let's just take a look. We're gonna use the QSH exec command, and so I'm gonna go ahead and prompt this. So you'll see we're talking about. So this example is just going to show doing this is a paste or a Q shell command to, we're going to change to a directory, and you can actually string multiple things together. So in this case, I want to change into that directory, and then I want to do a long listing of all the files in that directory. So you can actually string a sequence of commands right on the command line if you want to for paste commands. So we'll run this, and you'll notice I have display standard out set to yes. In fact, let's do this. We'll do we want to log, now we won't log it. We'll do a print one just so we can see what that looks like. And then let's say we'll put that in the IFS too, just so you can see what it looks like. All right, so we ran that. So you'll see all this did was generated a file listing from my RPG open source directory. And so if I were to go look at the output it created, if I go into qtemp, we talked about it's always going to create this out file, right? So this is basically a 1,000-character record that's a flat file that you can process from RPG. So if you needed to read this and scan through it yourself, just like we do with that scan log example we have, you can certainly do that. So it ends up there. If we want to look at, oh, I didn't do that one. Let's see where it displays on. So you see, this is our job log that it created. So I created, that's the default spool file name, but I could have overridden it. But there's where it logged all that information to a spool file because I told it to put it there. And then if I want to that same information is in an IFS file. So you have that option. And just for fun, we'll run this. Let's see what this does. Hopefully it won't blow up our IBM job, but we'll put these in the job log too. There's not that many files in there. And then I'm going to tell it also to append to my IFS log file so you can see that. All right, so I think it works. So if I do a display job log, you're going to see about 30 or 40 files listed in the job log. So you'll see, actually there's not that many, but you'll see that information, those messages are all part of my regular IBM job log. And if I needed to go through like doing a receive message, you can just look for that message from a CL or RPG if you needed to process these within your job log. Or if you just wanted them to show up there for auditing purposes, that's always a good thing as well. And then if we go back and look at the IFS log we created, since I told it to append to it, you'll see there's my first pass, and then there's my second pass. It just keeps adding to that IFS file. So some people have log reader applications nowadays, maybe have, they call it tailing, I think is, but you might be constantly monitoring log files and things like that that are stored in the IFS, but so that's a nice reason for putting those in the IFS, or just aggregating all the log information in one place. All right, cool. So let's do, this is kind of an interesting one. Let's do this one. So let's do, this one just does a ping. One of the things I learned is that you don't have ping directly available in the PACE environment, which I thought was interesting. So I ended up writing a shell script that does a ping, and it's actually, it goes out and it calls the regular IBM ping command. So it's basically an example of the PACE environment calling a regular IBM job to do a ping and then bringing back the result. So it's kind of interesting. So it calls a regular CL command from a shell script. So let's just see this one. So you can see it actually went out and it ran this command. This is the CL command. It ran over in the regular IBM job, and then it retrieved all that information back into my PACE job for me, and then made that information available. So I don't know why it's not available in AIX or in the PACE environment, but just that was just kind of an interesting reverse example of calling ping from a CL command. All right, so let's do this. I want to run this command again. So we're going to list RPG open source. This time we're going to say, we'll say display standard.no. So we just listed our files. We're going to look at our out file. So there's that qtemp out file we just created. And then we're going to scan for a specific value. So in this case, I want to scan for that ping sh. There we go. So I told it, so when I ran this, I said scan for, in my log in qtemp, I want to scan for this value. It has to be an exact match, which means that whole line has to have the word ping ish on it. And so if I run this, you'll see it threw a CPF message because it didn't find, I got a CPF 9898 escape message because it didn't find that exact value. But if I do a partial match, so if I say exact match no, it came back and it ended nicely because it did find that value. And I'll show you exactly why. So if I look for, where's ping I? There he is right there. So if you think about it, what that RPG program did that's scanning the log is it looked at this line. And if it looks for an exact match of this, it didn't find it because this whole line has more than just that information on it. So anyways, that's something you guys can play around with on your own if you decide to tweak it. But just to show you, that RPG, oh, that's another one. If you want to just see how easy it is to process that out file, that's essentially what this little RPG does. And I won't spend a bunch of time in here, but you'll see all it's doing is it's reading that file in, and then it's doing a set lower limits, and it's looping through the contents of the file, and it's doing a couple of scans in there. There's a couple of if statements in there, and that's it. So it's a very tiny RPG program, but if you decide to write your own custom RPG to scan these logs, very easy. Just take a copy of this particular RPG program and you can make it your own and do all kinds of fun stuff to scan those logs if you need to. All right, so we're going to do a quick hello world application in Python. So I want to show you, so we're going to run, I won't actually show the Python right now because I know we're running up against time. I want to make sure. So we're going to go over here. And actually I will show it to you just so you see it's a real Python script. So so it's basically a simple hello world Python script that we're going to use. So we're going to run this. We're going to show a couple ways to run this. So this might be one way that you've seen stuff run, or maybe you've run if you use an SSH terminal. And just before I go any further, if you get a chance, download a copy. If you like the way this looks, you'll notice I can actually run paste commands from a terminal here, but I can also edit and navigate the IFS over here. This tool is called MOBA Xterm, and they have a free version of it. I pay for it just because I really like it, but it's a great way to be able to edit stuff from the IFS and run commands from the IFS over SSH and that sort of stuff. But anyways, so let's change our directory. So we're going to do that. And then we're going to actually run our Python hello world command. Let's say, to show you that it works. Okay, that should work for us. So basically from the command line, we're going to type Python 3, and we're going to run that script, and then we send a parameter to it, and I want to take that off there. So you'll see it ran successfully, so that's cool. So I got all my output that I was expecting. So again, this is what we call standard out, right? So that's that information that comes back to us. So now let's see that same command run over on the IBMI, just to show you you're essentially getting, so there we got the output from our Python script. So if I go back to my IBMI to do the same thing, but we're going to now use the QSH exec command, and then we'll backspace a little bit of that message there. You'll see it's doing that same command line I just ran over in my SSH session, and then it's displaying it in my case, but you'll see there's that same standard out information. So just showing you that no smoke and mirrors, that's the same information that comes back from an SSH session right into your primary IBMI job after it went out and ran that Python script. So it's pretty cool. And all I did is specify that Python command line with a parameter on it, which is cool. Now, if you want to get a little more sophisticated, one of the other things you can do, we'll stick with hello world real quick. You can actually do a, so I tend to do wrapper commands. So rather than me always having to, let's say you build this for your developers or your users and they didn't want to always have to call this. A lot of times what I'll do is create a wrapper command on top of that. So there's one called, here's one I created called hello world. So if you've done CL commands before on the I, you'll see, I created a nice command. It takes in that message parameter, and then it has a couple of the standard parameters that are needed for this guy. So for being able to run the QSH exec command. So it's basically a wrapper over QSH exec, and you'll see the CL that it's calling, just to prove that that's all it's really doing. The CL is pretty simple. It takes in that parameter information, and all it's doing is making a call. Oh, actually, this one's calling our Python script, but it's making a single command call, and that's the only thing that's in there. So you can actually build your own layers on top of these commands to make it more meaningful and English-like. So going back to our hello world example, let's show why this makes sense. So now I could give my users a more meaningful command like this. So instead of having to know about QSH exec, maybe I give them something that's called hello world, and I can come up with my own named parameters that I pass into it that ultimately go to my Python app and essentially run the same stuff. So it's kind of the idea of building another, I call it you're dumbing things down for the end users perhaps. So there's hello world in that fashion. So let's look at a secondary example of that with send mail. So I'm just going to bring this one up. So since we're running late on time, I'm just going to show you. I did an example, and this will also be out on my site. But this example allows you to send an email message with Office 365. I think most of our shops nowadays are starting to move towards Office 365, but sort of stemming off the Hello World example I just did, I actually made a sample and I created a CL command called send mail Office 365 that is ultimately running a Python application under the covers. But what I did is I made this easy where you could actually prompt an end user for it if you wanted to. So you could allow them to type in a from email address. They could type a to email, email subject and a body, and then they could put an attachment in there and then run this guy. And you'll see, let's run this. And if it works as expected, it should send an email. So you'll see this just went and ran that Python script, and it came back with an exit code of 0, and it sent that email successfully through Office 365, and it landed in my mailbox. So I'll share that. We won't spend any time going through for today's session. We won't go through that Python application, but definitely kind of a useful application there. So next, let's take a quick look. This will be probably our last example we'll go through, but this is that RPG sample I talked about. So what this is going to do is it's meant to import JSON data from an RPG website to a physical file. All the work is called from the sample RPG program. It uses a simple JSON retrieval from the website. Then basically it reads that through Python from the website. Then it uses a component in RPG called, I call it YAGL, I guess, but Scott Clement has a library that parses JSON, and you can use that from RPG. And then it writes the output into a physical file. So kind of a pretty straightforward component, but let's do this. We're going to show you how that works. So this one will be really uneventful because we're just going to call JSON1, and it just ran, right? So that was pretty uneventful. But if we go look at it, oh, and actually I think we have it over in RDI. Yeah, there we go. It looks much better in RDI. So this RPG example, so if you'll see, it's pretty straightforward. There's all, for the most part, it's all freeform RPG, which hopefully most of us are using nowadays. But there's a wrapper that can call CL commands. There's a function or a procedure in here called QSH exec. So you can actually call the QSH exec CL command right from within here, which is pretty nice. So you'll see we set up an IFS file name we need to call. We give it a Python script we're going to call. And if you walk sequentially, it's clearing this temporary file for us. It's opening a database file. It's building a command line. If you go back to where we were calling that Python 3 with the script file and then the output IFS file, and then it calls QSH exec. So this is all it takes to run that Python application right from your RPG program is you build up a command line like I did here, and then you call this guy, and it's going to come back either a 0 or a non-zero. And you'll see in this case, if it comes back non-zero, I'm not doing any specific error handling, but it does bail out of the process. So it keeps it really straightforward to run those processes. And then if it comes back successfully, then I'm not going to go into how to use this YAGL library. You can actually work through this on your own because there's a number of samples on the web, but it loads that JSON file from the IFS, and then it goes through and finds the records because there's multiple records in there. And then there's a little do loop here that uses all the data from our QCustCDT example, and it peels off each field. So the custom, then it moves it into a data structure, the last name, init, street, city, state, zip, so all that information. And then it moves it into the fields for our record. We have a file called custCDT in here. And then it does a standard RPG write, and then it continues. And then that's pretty much it. It's done. It closes everything up, and it exits out of that program. So a pretty straightforward RPG application. But if you look at this, all this QSH exec procedure is doing, as you can see, is building a CL command call to QSH exec, and then it's making that paste or that Q shell call directly from RPG. So you don't even need to use an external CL if you don't want to. You can use this sub procedure to do all your calls to your paste and your Q shell applications. So from a takeaway perspective, I got asked this, and this will be on the recording as well, but just people were asking about how to get started with Python. There's a gajillion resources out there, but here's a couple. Cyden Group offers paid sessions, and I do some work for them. You can learn it on your own. There's some YouTube video courses. There's free code camp, and if you just Google on Python free training, you're going to find hundreds and hundreds of links And again, you don't have to learn Python, but since that was kind of the back end I was using for my language, everything we've covered today will work with Node or PHP or even just plain old shell scripts and that sort of stuff as well in conjunction with your RPG applications. So that's pretty nice. So it makes things really nice to use. So from a next step perspective, I would say, probably I would recommend next step is install the IBMI open source stuff, install Python, install the QShell-NI library, and then I'll have, hopefully by the end of the week, I'll have all my examples up on this GitHub site. So I would suggest if you're really interested in using this, or if you've got somebody, you're on the RPG side and you got somebody who's on the open source side today doing stuff, start a little project together to try using the QShell-NI stuff with a little Python script or even a simple shell command like we did with the directory list. But start creating your own shell scripts and give me feedback or share your examples. I'm always happy to put them on my open source site, but that'll give you hopefully a good kickstart into using RPG with all the open source stuff that we covered today. So a little fast paced, but hopefully you guys all found that useful.